Alright, so I'm going to be going through how you solve question number 53 and 54 from section 4.1. So question number 53 is asking for the absolute max and the absolute min of the function, and the function is f at x equals x plus 1 over x. And it also gives you your domain here, which is 0.2 to 4. So first thing I'm going to do is I'm going to write f at x as x plus x to the negative 1. This makes it a little bit easier when you differentiate the function, because you can use the power rule for this term here. So now I'm going to derive the function. So f prime at x is equal to 1 plus negative 1 times x to the negative 2 times 1, and this is because of the power rule. Then you can rewrite this as 1 minus 1 over x squared, if you just kind of expand this out. Now that we've rewritten this, we can set the function equal to 0. So I'll just rewrite that as equal to 0. And in order to subtract these two terms, we have to have a common denominator. So you're going to multiply this by x squared over x squared. So you're going to get x squared over x squared, and this you don't need to multiply because it already has x squared in the denominator, so that'll just stay as 1 over x squared. Now that you have that, you can write it as x squared minus 1 over x squared. And now that you have this, you can cross multiply, which gets rid of the denominator, because you're trying to find the critical points of the function. So you're left with 0 is equal to x squared minus 1. This is a difference of squares. So 0 is equal to x plus 1 and x minus 1. So given this information, your critical points are x equals plus 1 or minus 1. Now that you have this information, you're going to refer back to your domain, and you can see here that your domain is 0.2 to 4, which means that x equals negative 1 is not within your domain. So now that we've found our x values, we're going to check whether or not they are a max or a min. So we're going to plug our x values and our endpoints into our original function. So just I'll rewrite the original function, which is x plus 1 over x. So we're going to find what x equals 1 is. So we're going to sub 1 into our original function. So we're going to get 1 plus 1 over 1. So that makes our x equals 1 to be 2. Next we're going to check our endpoints, and our domain is 0.2 to 4. So we're going to check f at 0.2. So that makes it 0.2 plus 1 over 0.2. So to find this term, it would be 1 divided by 0.2. So 0.2 goes into 1 5 times, so that will equal 5. So you have 0.2 plus 5, which makes it 5.2. Next you're going to check f at 4. So f at 4 is equal to 4 plus 1 over 4. And 1 over 4 is equal to 0.25, so your point would be 4.25. So now that we've found all of our critical points, so f at 1, f at 0.2, and f at 4, we can now look at our y values, so 2, 5.2, and 4.25, and we're going to find which one would be our max and which one would be our min. So looking at all of our values, we see that our f at 1 value gives the lowest y, which means that we have an absolute minimum at x equals 1. And then if we look at the 5.2 and the 4.25, we see that the 5.2 is greater, which means that we have an absolute maximum at x equals 0.2. So next I'm going to look at question number 54, and number 54 is again asking for us to find the absolute max and the absolute min. So the function is x over x squared minus x plus 1, and our domain is 0 to 3 this time. So first thing we're going to do is we're going to derive this function, and the way that we're going to do that is by using the quotient rule. So I'm going to write f prime at x is equal to, so to do the quotient rule, we write the bottom term and we multiply it by the derivative of the top term. So that's going to come to x squared minus x plus 1 times the derivative of the top, which is 1. And we're going to subtract the derivative of the bottom, which is 2x minus 1, and multiply it by the top term, which is just x. And we're going to write that over the bottom term, and that bottom term is squared. So this is the quotient rule. So now we're going to collect like terms in the top. We're going to get f prime at x is equal to x squared minus x plus 1 minus 2x squared plus x over x squared minus x plus 1 all squared. So if we collect the terms, it's equal to negative x squared plus 1 over x squared minus x plus 1 squared. So now that we have this, we're going to set the equation equal to 0, and on the top term here, if we factor out a negative 1, we get x squared minus 1, which is a difference of squares, which makes that a little bit easier when we look for our x value. And we have still in the bottom x squared minus x plus 1 squared. So now that we're trying to find the x values, we cross multiply and that gets rid of the bottom term. So we have 0 is equal to negative 1 times x squared minus 1. Like I said before, this is a difference of squares. So that is equal to negative 1 times x minus 1 and x plus 1. So our x values are x equals plus 1 or x equals minus 1. And if we look at our domain again, once again, the x equals negative 1 is not part of our domain, so we don't have to check this as a maximum or a minimum. So we're going to check our function, our original function, which is f at x equals x over x squared minus x plus 1. So we're going to check all of our critical points that we found and our endpoints in this function. So we're going to write f at 1 is equal to 1 over 1 squared minus 1 plus 1. So this, if you do the math for it, it's 1 over 1 minus 1 plus 1, which makes this 1, which is 1 over 1, so 1. So now we're going to check our endpoints, which is one of our endpoints is at f equals 0. So f equals 0 is equal to 0 over 0 squared minus 0 plus 1. So that gives us 0 over 1, and that's just 0. Now we're going to check our last endpoint, which is f at 3. So f at 3 is equal to 3 over 3 squared minus 3 plus 1. So the bottom term, that's 3 squared, which is 9, minus 3, which makes that 6, plus 1 is equal to 7. So we have 3 over 7, and that's approximately equal to 0.43. So now that we've found all of our points, all of our critical values, we have f at 1 is equal to 1, f at 0 is equal to 0, and f at 3 is equal to 0.43. So now that we have this information, we can look for our absolute max and absolute min. So given these values, we have an absolute min at x equals 0, because we have f at 0 equals 0, and we also have our absolute maximum at x equals, it's between 4.3 and 1, so 1's bigger than 0.43, so our absolute maximum happens at x equals 1.